Hi guys. So we're going to be covering 7.3, simplifying complex rational expressions today. The learning objectives are being able to simplify a complex rational expression by writing it as division. And then our second objective is to simplify a complex rational expression by using our LCD, which is least common denominator. Synonym for LCD is LCM, which is least common multiple. So let's jump into it. We only have a few examples for this section, so it shouldn't take too long to tackle it. Okay, let's do some warm-up problems. The first one we're just gonna disregard because there's nothing there and it was a typo. So let's just jump into the second. We're dealing with a complex fraction where we're adding the numerator and then we're adding those fractions in the denominator, and then we utilize our whole keep change flip method. So anytime you're adding fractions, we need to make sure that the denominators are the same. How do we do that? We utilize our cake method in order to find that LCD. And what's the LCD between 5 and 2? Well, lucky for us, 5 and 2 are relatively prime, so we just take the product of those, and then boom, we get our LCD of 10. Now, we manipulate these fractions in our numerator by multiplying them by fancy forms of 1 to get that common denominator of 10. So that first fraction, I'm multiplying by 2 over 2, and that second fraction, I'm multiplying by 5 over 5. When I do that, I now have 4 plus 5 in the numerator all over 10, all divided by, and that I'm making that division sign a little larger so you can really hone in on this keep change flip that we're about to do. And then lucky for us in the denominators are already the same for these two fractions, so we can just do 1 plus 2 all over 10. When you end up utilizing the keep change flip, these two denominators, one shoots to the numerator, one shoots to the denominator, and we just get 1. So essentially what we're looking at is 4 plus 5, which is 9, all over 1 plus 2, which is 3, and this simplifies to 3 as your final result. And we are done. All right, let's continue. So we have our first objective that we're going to cover today, which is being able to simplify a complex rational expression by writing it as division. And so let's get into some terminology and definitions. Complex fractions are just simply fractions divided by other fractions. And we have a numerical example of a complex fraction off to the left here, whereas we have an example that involves variables or involves expressions in both the numerator and the denominator. And so throughout this section, what we're going to do is we're going to be able to simplify these. So we'll be able to find LCDs. We'll be able to both add and subtract fractions, multiply fractions, and then last and not least, we'll be able to utilize that whole KCF option, which is, or not option, method, which is keep change flip. So our definition of complex fraction, or in this case, complex rational expression, is just when we're dealing with a fraction divided by a fraction, but there are variables involved. And once again, we have some examples down here. This slide is just going through the formalized step-by-step procedure in order to simplify complex rational expressions. But there's no better way to really enforce these new learned skills than by tackling some concrete examples together. So let's look at this first example. Our numerator, our top fraction, is our 6 over x minus 4. And then this is being divided by 3 over x squared minus 16. So if you want, you can jump straight into keep change flip to look at it from a product perspective. And so when you do that, what is this going to look like? We have 6 over x minus 4 times x squared minus 16 all over 3. Now that x squared minus 16 is really standing out to me because that's a difference of squares. That can be broken up into x plus 4, x minus 4. And when you're multiplying, you're just multiplying all of the numerators and all of the denominators by themselves. So we can put this all under one fraction now. Why is this helpful? Well, an x minus 4 sticks out in both the numerator and denominator, which means those can be canceled out. And then what else can also be canceled out? Well, how many times does 3 go into 6? 3 goes into 6 2 times, so we're looking at 2 in parentheses x plus 4. And this is our final answer. All right. Why don't we jump into example 2 together, where we're not dealing with any variables, we're just dealing with some numerical values now. So once again, we have our numerator divided by our denominator, but in this case, our numerator deals with adding two fractions. So we have 1/3 plus 1/6. LCD between 3 and 6 is actually just 6, so we don't need to multiply that second fraction, we just need to manipulate that first one. So what are we looking at? We're looking at 2 plus 1 over 6, which is just 3 over 6. That's our simplified numerator, which technically we could simplify it more, but I'm not going to, and I'll tell you why in a moment. And then the second part, let's look at our denominator. Lucky for us, the LCD is once again 6, so let's multiply that first fraction by 3 over 3 and the second one by 2 over 2, our whole fancy form of 1. And when we do that, what do we end up getting? We end up getting 3 minus 2 all over 6, which gives us 1 over 6 as our simplified denominator. This yellow and blue are being divided by one another. And what do you notice? Those denominators are exactly the same. And so when you end up utilizing that whole keep, change, flip, those cancel out, and our final simplified result is just 3 over 1, which is just 3. And we're done. Okay, let's continue to trek along. So now we have example 3, where we're dealing with some expressions. We're dealing with variables now. And we're adding two fractions in the numerator once again. We're subtracting two fractions in the denominator once again. Find the LCD. That is the key. We have 1 over x plus 1 over y. What's our LCD here? It's just the product of the two multiplied by your fancy forms of 1. And we're essentially looking at y plus x all over xy. Made a mistake over here. This should be x over x. And so now we have this fraction. Now let's look at the denominator. So denominator, we're looking at x over y minus y over x. Once again, LCD is just the product of the two since they're relatively prime, multiplied by your fancy form of 1. And you're looking at x squared minus y squared, which, ooh, fun fact, that's a difference of squares. We'll be able to factor that in a moment. Now we're dividing yellow and blue by one another. Keep, change, flip. Lucky for us, denominators are the same, so they cancel out. So we essentially are looking at y plus x, which is really the same as x plus y, all over x squared minus y squared, but this is a difference of squares, which means we can factor this into x plus y in parentheses, x minus y. And why is that important? No pun intended. It's important because now we can cancel out an x plus y in both the numerator and the denominator. So our final result is really just 1 over x minus y. And we are done. It's all about getting into the rhythm of the systematic procedure. And once you practice this rhythm, then you can do any sort of complex fraction like this. All right. So now let's jump into example 4. It's getting a little bit more complex, but it's not too bad. Once again, simplify the numerator, simplify the denominator, find your LCD. It's looking to me like the LCD is going to be, for the numerator, it's going to be n plus 5. N as a fraction is n over 1, so we're going to multiply that by n plus 5 all over n plus 5. When we do that, we end up getting n in parentheses n plus 5 minus 4n all over n plus 5. And then we can simplify that a little bit more. Let's utilize our distributive property. We have n squared plus 5n minus 4n. Combine some like terms, and this is just n squared plus n all over your n plus 5. Now let's take a look at that denominator. What's our LCD for the denominator? It's the product of n plus 5 and n minus 5. And so we're going to multiply that first fraction by n minus 5 over n minus 5. And that second fraction by n plus 5 over n plus 5. So what do we have? We have n minus 5 plus n plus 5 in the numerator, all over n plus 5 and minus 5 in the denominator. Now we can go ahead and combine some like terms from that numerator. Our n plus n gives us 2n. And then a negative 5 plus 5 cancels out. So we end up with 2n all over n plus 5 and minus 5. And now we take our yellow and divide it by our blue. So I'll bring it down here so you can really clearly see what's going on. And you'll notice in the yellow that n squared plus n, we can technically factor out an n. But let's do that when we're keep change flipping. So that n squared plus n, we're going to factor out an n, and we're looking at n plus 1 all over n plus 5, because again, when we keep that first fraction the same. We keep the yellow fraction exactly the same. We change the division sign into a nice, beautiful multiplication. And then we flip the blue fraction, so now it's looking like n plus 5 in parentheses n minus 5 all over 2n. So from here, you can clearly see that this is all just one giant fraction when you're multiplying. You just take the product of the numerators and then you take the product of the denominators. And so the n plus 5 in the denominator over here cancels out with the n plus 5 in the numerator. But what also cancels out, this n over here cancels out with this n over here. So what's our final result? Our final result is simply n plus 1 in parentheses n minus 5 all over 2. And we are done. We're doing excellent work so far. Again, if you feel the need to pause, do the problem again on your own, rewind, feel free to go ahead and do that. We're finally on our second objective, which is our last objective for today. And that's being able to simplify a complex rational expression by using our least common denominator. So we cleared the fractions by multiplying by our LCD when we solved equations with fractions. We can use this same strategy here to simplify complex rational expressions. What we're going to do is we're going to multiply the numerator and denominator by the LCD of all of our rational expressions. So essentially everything that we've done in these past few examples, we're just doing it again. We're just dealing with rational expressions and really honing in on using our knowledge of least common denominator, aka utilizing our cake method strategy if we have to. And then this slide is just the step-by-step procedure in order to simplify a complex expression. So you want to find your LCD and then multiply the numerator and denominator by that LCD and then simplify. So let's do example 5 together. And so our LCD here for that top yellow fraction is the product of x, y. Now we're going to multiply by our fancy forms of 1. So we have y over y. Okay. And then for the 1 over y, let's multiply that by x over x. So we're looking at y plus x over xy. Now that denominator, we have our LCD happens to, lucky for us, be exactly the same, xy. We're just going to multiply that first fraction by x over x, that second one by y over y. So we're looking at x squared minus y squared all over xy. And because the two denominators in that top and bottom fraction are the same, they cancel out. So we're essentially just looking at x plus y, it's the same as y plus x, over x squared minus y squared, which is a difference of squares. So we can factor that into x plus y, x minus y, and then we have that x plus y in our numerator. X plus y and x plus y cancel out, so our final result is simply 1 over x minus y, and we're done. Let's jump to example 6. Bottom fraction, we're going to end up simplifying. Our top one can sort of keep as is for now. So we have this 2 over x plus 6. Keep, change to multiplication, and then flip, but let's simplify this first. So x squared minus 36. Difference of squares, x plus 6, x minus 6, which happens to be our LCD for this part of the problem. And multiply that first fraction by our fancy form of 1, x plus 6 over x plus 6. Utilize distributive property, so we're looking at 4x plus 24 in our numerator, and then this whole x plus 6, x minus 6 in our denominator. Combine some like terms. 24 minus 4 is 20. So what do we end up getting? We get 4x plus 20. And actually, I'm going to write it here because in our keep, change, flip, this is going to jump to the denominator, all over x plus 6, x minus 6. And then 4x plus 20, we can actually factor out a 4. So we're looking at x plus 5. And then we have x plus 6, x minus 6. All right. Anything cancels out? Yep. How many times does 2 go into 4? It goes in twice. 2 goes into 2 once. X plus 6 in the numerator, x plus 6 in the denominator. Final result, x minus 6 all over 2 in parentheses x plus 5. And we are done. So these are just some additional workbook exercise problems for you guys to check out to further enforce your understanding of this section in our course. But this does complete our section 7.3. I hope it was helpful. Let me know if you have any questions, and I will see you guys next time. Take care.